All right, last video for 2.1, we're going to talk about how to standardize scores or create a z-score. By the end of the year, you are going to be so sick of talking about standard deviation and z-scores, I promise. But actually, I love it. I like using z-scores. I think they're lovely. All right, so let's go ahead and talk about what is a standardized score. So when we take a measurement of an observation and then convert it from its original value to standard deviation, the number of standard deviation units in relation to the mean of all observations. So that is the very formal definition. So once we do a few problems, I think you'll understand what it is. And actually, maybe when we take a look here at the formula, which is what we're going to do next. So the next question asks, how do you calculate and interpret a standardized score or a z-score? So let's start out with the formula. The formula for calculating the z-score is your x, which is your single observation, subtract the mean and divide that value from the standard deviation. And the interpretation of a z-score will always be this. So we'll say something like an observation X is Z standard deviations above or below the mean. So your observation is what you're measuring. Your Z is your new calculation to tell how many standard deviations a value is above or below the mean. So I said it twice. Do z-scores have units? So usually when we do measurements like your height, that's in inches, that's your unit. Speed would be in maybe units of seconds or hours and miles per hour. Those all have units. So do z-scores have units, measurable units like that? So a common mistake in z-scores is that students will say it's a z-score is 3.9 standard deviation inches or 3.9 inches. It can't be. So no, the original observation's units no longer matter. Everything is now relative to the mean and the standard deviation. So please don't ever, and this is a common mistake, they will get you for this one on the AP exam if you write a z-score with units, inches, height, minutes, whatever. Okay. Last thing, what does the sign of a standardized score tell you? So a positive z-score is the distance in standard deviations an observation is above the mean, and a negative z-score, of course, would be below the mean. So pretty simple. You can get negative z-scores, so that just means your value fell below the average of the mean. All right, let's take a look at an example, and I think it'll bring it all together for you. Example 3 says, according to the Centers for Disease Control and Prevention, the heights of 3-year-old females have a mean of 94.5 centimeters and a standard deviation of 4 centimeters. So I'm going to underline some key information. 3-year-old females, mean of 94.5, standard deviation of 4 centimeters. The mean height for 12-year-old males, I'm going to switch colors because we're talking about something different. Mean height for 12-year-old males is 149, standard deviation of 8 centimeters. Macy is a 3-year-old female. She is 100 centimeters tall. Brody is her brother, a 12-year-old brother who is 158 centimeters tall. Obviously, Brody is taller than Macy, but who is taller relatively speaking? So that's what a z-score tells you, is relative to other kids their same ages, who is taller. So let's take a look at Macy. So for Macy, her z-score is going to be her height, which was 100 centimeters. And then we're going to subtract the mean of other children, or specifically girls, her age, and we're going to divide that by the standard deviation, which is 4. So when I subtract, I get 5.5 divided by 4, and then her z-score is 1.375. Okay, then Brody. So Brody, we're going to do the same thing. So Brody's z-score, we find his height, so he is the observation, minus the mean for boys of his age, 149, divided by the standard deviation, which was 8. So 158 minus 149, that's going to be 9 divided by 8, which is 1.125. All right, so we can see that relatively Macy is taller than Brody. So now we need to be very specific with our answer here. We need to compare, and we need to talk about what we are measuring. So your answer might look something like this. Macy's height is relatively higher than her brother's. She falls 1.375 standard deviations above the mean, while her brother is only 1.125 standard deviations above the mean when compared to other children, their ages and gender. All right, so let's talk about speed and the AP exam. It is okay to abbreviate standard deviation with an SD. So that is fine. The readers do realize, I was still in print mode there, the readers do realize that you mean standard deviation if you use an SD. There are also two symbols, but you need to be careful with them. The sigma means standard deviation, as does the S of X. When we get into it, we'll use the S a little bit more. The S comes from a sample. Sigma comes from a population. You'll need to know the difference. So right now you're safer just using SD. When we get later in the year, you'll be able to differentiate between the two symbols for standard deviation. There's also a third one, S of X bar, when we find the standard deviation of means. Totally something different. So you're going to see 3 different symbols for standard deviation, and you need to know the difference between all 3. So right now, play it safe. If you used SD on a test or on the AP exam for right now, I would know what you meant. You'd be safe. All right, but when we use formulas, we're going to use one of these 3. So just a little side note there to get you ahead. All right, so hopefully that helped you out, and I'll see you back in class, and let me know if you have any questions on this one.